Hello, my name is Mariana Lopez Jaimes, and I'm a senior in computer engineering at North Dakota State University. Today I'm going to present my senior design project. This project was developed to meet some educational requirements of the computer engineering program, but it provides a wonderful hands-on experience. There are not many good options for an electronic chessboard, and it is precisely for this reason that the objective of this project is to build an affordable, open-source electronic chessboard that uses light-dependent resistors to detect what's going on throughout a game of chess. The project is basically composed of software and hardware, and it is known as ChessPi. For hardware, we chose to work with those LDRs because they are affordable and easy to use. However, they lack accuracy. The brain of the project is a Raspberry Pi Model B. It is open source, low cost, but the main reason to choose it is that it has a wonderful developer community. The two disadvantages that we saw for this project is that it lacks A2Ds and there's just 8 GPIOs to interface. To solve this problem, we chose this model of GPIO expansor and this model of A2D converter. The protocol of communication that we are using is I2C. We I2C because it allows us to use few wires and to connect several devices. For software, we're using C++ to determine the logic of how the pieces should move and behave, and Python to create a graphical user interface. The trust-driven development approach was used to write the software throughout all the process. The main architecture of the software consists of 3 layers. The physical layer collects the data from the actual physical chessboard. Then the logic layer determines if the moves made were valid or not, and then the presentation layer gives feedback to the user via graphical user interface. These are the 3 main capabilities of the graphical user interface. As you can see, colors were used to indicate and to allow the user to know what's going on when he or she is playing a game of chess. During the building of this chessboard, we first started to drill holes and place LDRs in the middle of each square. Then we connected those LDRs in a key matrix configuration, as you can see in the image of your right. And we connected a ribbon cable that will feed voltage to each of the 8 columns. We will read the data from the sensors from each of the rows. This is the development process of a printed board circuit that we designed for this project. We started from breadboard, then we made an in-house prototype in a milling machine at the computer engineering department, and finally, on your right, you can see the final PCB. We decided to use sockets in case there is some component that burns out. It can be easily replaced. This is how the chessboard looks. You know, as you can see, there is an actual physical chessboard connected to a computer. The module that contains the screen is made out of 3 pieces: the Raspberry Pi on the bottom, the PCB that we designed in the middle, and then a color screen for the graphical user interface on top of that. There are 3 buttons that are used for the 3 main functionalities of the graphical user interface, and a 4th one which is unused and is open to future development. Finally, we would like to acknowledge our advisor and our professor because they provided great guidance, and our technician of the electrical and computer engineering department. Without him, we wouldn't have been able to complete this project. Finally, we would like to thank the electrical and computer engineering department for the support and the funding provided for this project.